So today, guys, we're going to be looking at synthetic division and how we can complete a synthetic division problem. There's a couple of problem areas that I find with using synthetic division, so I just want to take a moment to talk about those with you today. So here I have two polynomials being divided. If you look up on the top right here, I have 2x cubed minus 3x plus 4 divided by x minus 1. And so the first thing we want to do with our synthetic division is go ahead and draw our box. And we're going to go ahead and figure out what number should go in the box. So when you're looking at what goes in the box for synthetic division, you're looking at the divisor. So x minus 1, I want to know what x would equal. So here, x would have to equal 1. That's what goes in the box. And that's one of the first places we see a mistake here, is because students use the wrong sign in the box. So when we're trying to figure out what number to put in the box, we want to be specific and make sure that we're setting that divisor equal to 0. Now we're going to list the coefficients. So if we look, the highest exponent is x cubed. The number in front of it is 2. And then we have to go in descending order. So that because x cubed is the highest, I'm looking for an x squared. There's no x squared in my problem, so I have to put a 0. That's really, really important that you put a 0 for any missing terms. Then I have x, and it's minus 3x, so it's a negative 3. And then I have my 4. So now I've kind of built the framework for my synthetic division problem. So I'm going to follow the steps. The first step is that you drag the first number down to the bottom, okay? So it just goes straight down. Then you're going to multiply what's in your box times that number, and that's going to give you 1 times 2 equals 2, okay? So that's how we're flowing. The flow here is multiply what's inside the box, and then you're going to put it up here. I'm going to add these two numbers. 0 plus 2 is 2. Then it starts over again. I'm going to say 1 times 2 is 2. So that's where that's coming from. I'm going to add them together. I'm going to get negative 1. I'm going to, again, multiply 1 times negative 1, which gives me negative 1, so I have a 3. Now, there's a couple of important things to note here. This is called the remainder. The remainder is important because if you get a remainder of 0, that means that you have an even division and that whatever this is a root of the original polynomial. So it's factorable by that, okay? Factorable is what we're looking at here. This is not factorable by x minus 1 because that remainder is something other than 0. Now to write our new polynomial that we obtained through division, so synthetic division is replacing long division, I'm going to have 2x squared. Notice that x squared is 1 less than what I have in that parentheses. That's because I'm dividing by an x. Plus, I'm going to go descending, 2x minus 1, and then my remainder is going to go over the original division problem. So these answers aren't pretty, but they are definitely answers that we can utilize. So if I had done the process of a long division of polynomials, it would have taken me a lot longer, and I probably wouldn't got to as neat of an answer as quickly. So that's how you guys do synthetic division. Remember to watch out for what goes in the box. Remember to watch out for any of those missing terms so you can remember to put a 0 in. I hope this was helpful.